our learning targets. Okay, I can create quadratic regression from real life situation, and I can use a quadratic regression to make predictions. And that's the entire thing we're going to do right here. So, quadratic regression. Do you guys remember linear regression?
Oh my God.
Remember in the calculator, you hit stat, then enter, and you enter your stuff into L1 and L2, and all that jazz? Well, guess what? This is all the same. It is exactly the same as that, with one minor change at the end. Instead of, after you put in your L1 and L2 columns, instead of selecting linear regression, we now want quadratic regression. All you do is select quadratic. That's it. That's the only difference. Okay? That's the only difference. Everything else is the same. Alright. Let's create a table that shows or predicts today's hourly weather from WeatherBug from 8 a.m. to 6 p.m., okay? We're going to go every other hour. We're not going to do every hour from 8 a.m. to 6 p.m. We'll do every other hour. Oh, perfect. Bam. I hit WeatherBug. There it is. Ready? Today's weather. It is 64. Mm-hmm. Yeah, I know we'll get there. Stop it. 80% chance of rain. Of light rain, by the way. Okay, so at 64, it feels like 64. That's currently right now. If I go to hourly, I can't go back to 8 a.m., can I? Those stinky, stinky people. So we'll start at 10 a.m. and go to 6 p.m. Okay? So at 10 a.m., it's supposed to be 68 degrees. See that? So on that table, next to 10 a.m., make sure you record 68 degrees. At 12 p.m., it's also supposed to be 68 degrees. What is it right now? So the current temperature was what? 64. Why don't we go 2 degrees, just for the sake of the table? Why don't we call 8 a.m. 62? Let's make 8 a.m. 62 degrees. Okay. So now, the next one, the next one is 2 p.m. 68. What about at 4 p.m.? 64. And what about at 6 p.m.? 59. We're going to take those numbers and we're going to put them in that table in your notes. And I'll put them up here as well. So does someone have them all written down so I can copy them up here? What was 12? 68. So right now we said we were going to use 62 degrees, right? 68, 68, 68, 64, 64, 89. Good. We are going to take this. Wait for it. And we're going to put it in the quadratic regression of the calculator, and we're going to start to answer these questions. But I'm going to stay here just so I can see this, okay? And I'm going to open up our calculator. All y'all, if you don't have a calculator, get one. Okay, if you don't have a calculator, get one. And I do. But this is the background's white instead of gray. So now, how do I start this again? First, before you do anything, clear the calculator. It's seconds plus 7, 1, 2, and enter. It's completely cleared out now. Okay? Again, if you don't know it, second plus 7, 1, 2, and then enter, and you're good to go. Alright? So now, how do I start this whole process for regression? Stat, edit. I hit the stat button, and choice 1 is edit right there. I hit enter. I'm going to put my time into L1. So what's the first thing I type in? 8. What's the next thing I type in? 10. What's the next thing I type in? 12. What's the next thing I type in? 14. If I do 2, this goes numerically. Shouldn't 2 be before 8? So I should use military time. 2 more hours after 12 will be 1,400 hours. See what I'm saying? 14. So 2 o'clock is going to be 14. which means what is 4 going to be? 16, which means what is 6 going to be? 18. Because all I'm doing is adding these numbers to 12. So 2 plus 12 will give me 14, right? 4 plus 12 will give me 16. 6 plus 12 will give me 18. Because I don't want these points. If it plotted my 14 at 2 instead of 4, that would be before 80, not after. And that's where the issue would come, okay? So we have 1, 2, 3, 4, 5, 6. I move down, there's my 6th entry. So now I move to L2 and I put in the degrees. Should I, oh, never mind. We'll just put in the degrees. 62, 68, 68, 68, 64, and 59. All right, okay. So, I do. Now, what do I do after this? I go stat, and then I want to calculate my regression. So I need to move over to the right, so I'm going to calc. Everything has been exactly the same at this point. Here's where the one difference happens. I don't want a linear regression anymore, which is 4, which we've done. I want a quadratic regression, which is 5. Now, when I hit enter, you're going to see this list right here. Does anybody remember? I don't want to get this huge equation and write it down, then I have to type it in myself into y1. So what do I do so the calculator puts it into y1 for me?
Bars.
Not yet. Hold on. We will. Eventually, though, we will. Yeah, I want to store my regression into y1. So anyone remember how to get y1?
Yes.
Okay. I hit bars.
Y1.
I can hit enter twice here. I can hit bars, move over to y, and hit enter twice. Bang, bang. There it is. Now, you won't have to write it down and type it back in after your handwriting. It will store it right to y1 for you. Now let's calculate it. Hit enter. There you go. That's your equation. Now, if I want this equation to the nearest thousands, just 3 decimal places, how do I write this? In fact, let's do this. Hasty. Oh, it's crazy. All right, so I say, well, nearest 10,000. It's even better. It's even more accurate. Y equals. Right. Before you get going, does everybody know how to read this right? The A value here is this A value here. 10,000 is how many decimal places? 4. So I'm going to look at this 9. Will that stay 9 or move up? It'll move up. So that'll go from 6/9 into 70. So it is negative 3.3170 x squared. Plus my b value next to my x. That's my b value. So plus 7 what? 8554, because that will round up. 8554x. All right. Last but not least, my c value plus my c value. There's my c value. Plus 19 point what? Right, 9786. That is our actual regression right there. That's it to the nearest 10,000. Okay, let's use our model to predict the high temperature for the day. So you guys have this already written in the previous question. You're going to use this to predict the high temperature today. There are 2 ways we can do this. One is we can use the graphing calculator. The other way is we can do it algebraically. If I want to do it algebraically, now this parabola, does it open up or down? It opens down because my A value is negative, correct? So it opens down. So if I want to find the vertex, that's the point, X and Y, right? I need to find the vertex. So I need to find my vertex. That will give me an X and Y value of the max point, right? Because this parabola opens down. I want this point right here, the vertex. what does my x and y represent? What does my x represent? No, what does these values represent? Let's go back to this x, time and temperature. So, when I go here, this is time, and this is temp, right? What are they asking us for? The high temperature for the day. So I need to find the vertex, but more specifically, the y coordinate of the vertex. Because that's going to give me the temperature, the high temperature. The x will give me what? The time that the highest temperature occurs in the day. Okay? So we need to find this. Well, I can't just find this. I got to find one of them first. Can I find one of the... Yes, the axis of symmetry, remember? That's x equals negative b over 2a. Once I get my x value, I can find my y just by plugging it in. You got it. So what is my b value? Yeah, it's 7.8554. So I negate 8.554. Yeah, I know. All over 2 times my a value, which is negative 0.3170. Put that in your calculator and tell me what you get. I'll do it up here. Let's see if we get the same thing. Bam. And let's see. What did you guys get? Did I miss a decimal? Did you do 0.7 or did you do 7 point? Oh, you know what? When you did your parentheses, make sure you put your denominator in parentheses. Because if you don't, it'll divide and send by 2 first, then multiply by 0.3. You want that 2 to multiply by your 5. Don't forget, if you can always use alpha y equals. And type it in this way. And alpha y equals enter. This you will never do that error here. So I can say negative 7.8554 over 2 times negative 0.3170. Make sure you get 12.3902. Yeah, one of your decimals off. You took that 1.2. I know a decimal was off, so get the right digits. Decimals off. So if this is time, we'll just go 2 decimal places. This is 12.39. That's the time. So how do I figure the temperature at this time? I plug it from my axis, and I'm gonna show you something, children. I'm gonna show you something. Do you know the store feature? I can store a value. I'm gonna take this value right here. I'm gonna take my 12.39 whatever, and I'm gonna store that into the variable x right now. You see this button above on says stow? If I hit that right now, it's going to take whatever answer I have and store it wherever I want to store it. I'm going to store that right in X. Okay? So once I enter, bam, there it is stored. So if I want to know what's an X, there it is, that's an X. So now guess what I'm going to do when I type this equation in my calculator? I'm going to leave the X in there. Because now I don't have to retype this because that 12 is already in the X. Okay? So we have negative 0.3170 times x squared. I can do that now because my x is 12.39022, whatever in it. We're good. I don't got to retype that out. What was next? Plus 7.8554x, right? Plus, what's the last thing? C. 9786. What did you guys get? When you hit enter. I'm not going to do it in a second. You guys look at it. I'll make sure you guys see. 68.643. Let's go 1 decimal place because it's temperature. 68.6. So if I do this here, I get 68.6. So how did I do this? I take my y, and I have negative 68.3170 times my x value. My x value is now 12.39, and what was the y value I got? 68.6, we'll call it. So this is 12.39 squared plus 7.8554 times 12.39 plus 19.9786. And that equals my y. That equals 68.6 degrees. I mean, does that make sense? According to our table, I mean, the high temperature, it was 68 degrees, right? At noon, at 2, at 4. So the high temperature should be somewhere around 68 degrees. And according to our model, it's 68.6. Okay? So that is the high temperature. Now, that seems like a lot to do when you get the calculator to do it for you, doesn't it? Yeah. Let's look at the calculator right now. Remember how we put our equation to y1? If I hit y equals, look what's in y1. Oh, that's not truncated though. That's like the 10,000. That's as far as it can go. You have to type that in. Now, Cameron, hold on. Okay? So, yes. Yeah. It should be, because this actual change based on the table. Okay? Now, but that's a good question. So, if I look at my window, don't you think I should change it? If I graph this right now, I mean, there I see it there. Gone. It goes way off. I should change the window. What do you think my x should go from, the range? Look at the table. It goes from 8 a.m. to what? And how do we represent it? 6. 18, right? I'm looking back at this right here. I want to go from 8 a.m. to 18, which is 6 p.m. So I will go 8. Let's go 7. We'll go 1 back. To 19. We'll go by 2s. I don't care. All right? What about the y? At least 58, because it's the lowest point in my y's. You can do anything. Anything where you can see it. 58. We'll go 58 to what? 70 maybe, because the highest is 68. So we'll go from 58 to 70. We'll also go by 2s. Why not? Now, I'm going to do one more thing. When I go back to y equal, Shar, what am I going to do? Yeah, you don't have to do this, but that gives us a good idea of the actual points compared to our regression. When we graph this, there you go. It's pretty good. Kind of does. Now, what do I need to find the high temperature? I need to find the vertex, which is considered what? If I want to calculate something, I go to second calc. I don't see vertex there, so what do I use? The max. And I make my bow tie. I hit enter. And I want to go to the left of the max, because it's asking me the left bound. Sure, so I got to go to the left. I mean, the top is somewhere around there, so I'll make sure I'm really left of it. Well, that's left right there. I hit enter. Now it's asking me, you go to the right bound. Okay, well, I'm going to make sure I go to the... There. You guys can hold yours down and it'll slide much smoother. Okay. That thing, just keep it going. It's like that yodeling thing in the press. It's going to fall. No. Before your time. I see you guys. Yes, he's great. Hey, enter one more time. I'm saying you want me to guess? Sure. Bang. 68.64. Exactly what we got. We did it algebraically. 68.6. Is that cool? Did I do 0? What do you mean did I do 0? Oh, you mean what function? Max. I want to pick the maximum. Because that's the vertex. Because the parabola opens downward. So I have a max. What if the parabola opened upward? What would I have to do? I'd have to find the minimum. Absolutely. Now, do you think this is a good model for the day? Let's look at our table. Let's look at our table. Okay, well, if it was at 6 a.m., the temperature was probably 55 degrees. At 6 a.m. it's 55 degrees. What was the temperature at 8? What will the temperature be at 8 p.m.? Well, at 8 p.m. it's what? The number 20, isn't it? Is it 6 p.m. or 8 p.m. will be the number 20? Maybe 50 degrees. But why is this model not really good for temperature beyond today? Because the parabola is going to go down forever. Do you think maybe at the 35th hour, which there are not 35 hours in a day, there's only 24, it's going to reach negative 93? No. So it's only for set time periods. Okay? So, with that being said, look at this. We got our answer, 68.6, which is great, because look at that, it was 68.64. That was really accurate to what the calculator got the max at. Money, money, money. Money, money, money.